All right, here we have 6, which is solving logarithmic equations. And the first property we do in here is really, really simple. It's a common sense property. Make sure you fill that in that box there. But it says if two logs are of the same base, then they have to equal each other. That's all it says. So if b, x, and y are positive numbers, so long as b is not 1, because that would be weird, or 0, then the following must be true. You can't have base 0. But anywho, if I'll get plugged in, we'll do this example here. This won't take us too long. All right, so here's our common sense example. If a log base 4 of x is equal to a log base 4 of 3, then what must x equal? Well, if you want the left to look like the right, I believe that x would have to be a 3. So x is equal to 3. Now that's as easy as it gets, obviously. That can't be that easy. All right, solve and check for extraneous. So the first thing we do is we make sure we have the same base. And if two things have the same base, we just use this property. I know that 4x minus 7 must equal x plus 5. All right. Subtract x, I'll have 3x. Add 7, I'll have 12. And this tells me that x is 4. Now you see where it talks about checking for extraneous? So there's two big things here that you need to be writing. You need to write this, okay? An extraneous solution is a solution that makes no sense. Just it won't work. Also, what you need to be writing down is you need to be writing down the domain of a logarithm. All right, so for a log, ln, doesn't matter what's base. For a logarithm with argument a, the argument is bigger than 0. You need to write that. You need to know that. So I'm going to plug in my 4 here. 4 times 4 is 16. 16 minus 7. I need to be checking that. I know that 4x minus 7 is bigger than 0. So x is bigger than 7/4. That works. I know x plus 5 is bigger than 0. X is greater than -5. This guy fits the bill. Both sides are happy. All right. Next one, I do have bases of 4, so I can take the contents or the arguments of the logarithm and I can set them equal to each other. We've been working on these since August. We're just going to move everything left and probably factor. Yeah, factoring's in there. Factors of 5 are going to be 1 and 5. The product has to be negative, but the sum has to be -4. So that'll do it. Using the zero product property, x is -1 or x is 5. Now, let's go back up here and let's look at the domain of these things. X squared has to be bigger than 0, okay? And 4x plus 5 has to be bigger than 0. So this one I'm going to solve. 4x greater than -5. X is greater than -5/4. -1 is bigger than -5/4. And if I square a -1, I get a +1. If I square 5, I get 25. 5 is bigger than -5/4. These are both real. They are both real. They both work. So we're good to go on that one. All right, here's a U try. This one's old. It's going to have to be pushed on the worksheet, but just an old solving a logarithm. We did some of this last week to some degree. We're just going to play the isolation game. We're going to isolate. All right, we're going to isolate the log. So we're going to subtract 5, a log base 3 of 2x minus 12 is 13. Ooh, this thing's going to get big. Wow. I don't even know if a calculator will be able to do that. Let's change this up a little bit. And I'll make sure I modify the notes. Let's put a 5 out in front of here. And let's make this a 20. All right, so still going to do that. I'm going to have a 15. Now I'm going to divide out my 5. Now I have a log whose base is 3, whose argument is 2x minus 12, and it equals 3. All right, so now we're going to do the whole idea of log is bay, and you should probably be writing this down if you don't know this, because this is what it's all about. I have a base, I have an argument, which means this is my exponent, okay? 3 to the third must equal 2x minus 12. 3 cubed is 27. We're going to add 12. 39 is twice x. We're going to divide by 2. 39 halves. Now, does 39 halves work? So check your domain. 2x minus 12 is bigger than 0. 2x is greater than 12. X is bigger than 6. Yes, this is a real solution because 39 halves is bigger than 6. And you should know that. You should. All right, solve by condensing and then doing a process called exponentiating. That's where you convert into exponential form. So we're going to need some properties of logarithms. I'm going to write the shortcuts, and again, you need to know these. A log of a over b is a log of a minus log b. A log of a times b is a log of a plus log b. And finally, I don't think it's used in this set of notes, but a logarithm, argument a raised to the r, is r logs of a. Anywho, we're going to do some condensing. Basically, what you're going to do is, for these types of problems, is you're going to get logarithms on one side and everything else on the other, and then you're going to condense and isolate. So logs on one side, don't care if it's left or right. Condense, isolate, exponentiate. I misspelled condense, didn't I? Needs an E. So, let's take our logs on one side. This guy, this little guy right here, we're going to shift it left. And that is going to make it a negative. We had a negative 2 on the right. We're going to go ahead and shift that 5 over, make it positive. The right-hand side's easy. Negative 2 plus 5 is 3. And we are condensing this. We worked on this in class Tuesday. To condense, we do division. Sorry, if a logarithm is positive, its argument is in the numerator. And if a logarithm is negative, its argument is in the denominator. So this is what we have, all right? Now we're going to go through the process of exponentiating. So we need to identify our pieces because this log is all by itself. We have a base. So everybody see me changing colors here? This thing just doesn't like me. We have an argument, which means this is my exponent. So the base is 4. It is going to be cubed, and it equals 3x plus 2 over 2x minus 1. 4 cubed is 64, and it equals 3x plus 1 over 2x minus 1. All right. I used to push cross multiplication a lot, but then kids couldn't do it. I don't know why. I'm still going to, because it's the easiest way to do this. We're going to cross multiply. 64 times 2x minus 1 equals 1 times 3x plus 1. It's just cross multiplication. Use the distributive property. We'll have 128x minus 64 equal to 3x plus 1. We're going to get our x's on one side and our numbers on the other. That'll be 125x equal to 65. and then we'll divide by 125. So x is 65 125ths, which reduces down to 13 over 25. Because both pieces are divisible by 5, so 13 25ths. Now the question is this valid? All right, is this a valid answer? So we're going to check our domain. 3x plus 2 is bigger than 0, so x has to be greater than negative 2/3. Okay, we're working here, we're good. 2x minus 1 is bigger than 0, x is greater than 1/2. We're good. It's a real answer. All right, moving forward. Solve by condensing then exponentiating. So the property on this particular page is going to be that a log of a times a log of b is log ab. That's our property. We condense addition through multiplication of the argument. All right, so we have the ln with our understood e's, by the way. Its argument becomes x times x plus 2, because we condense addition through multiplication equals 3. I have a base of e. I have this stuff as an argument, which means this is my exponent. It's time to go ahead and exponentiate. E cubed is, now we'll go ahead and FOIL, or not FOIL, distribute, x squared plus 2x. This is a tough little problem. This is a very tough little problem if you want to do it by hand. It really is. So 0 equals x squared plus 2x minus e cubed. Now, how on God's green earth do you solve that thing? How do you do that? You do a little game of x equals negative b plus or minus square root b squared minus 4ac all over 2a. You sing the quadratic formula, kids. A is 1, b is 2, and c is negative e cubed. So again, it's x equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, so we have negative 2 plus or minus 4 plus 4e cubed. Both pieces sitting over a 2. That's negative 1 plus or minus. Here's something cool, and this probably only applies to about 5 of my kids, maybe 6 or 7. But root 4 plus 4e cubed is a root of 4 times 1 plus e cubed, which is 2 roots of 1 plus e cubed. You can simplify those things. And I forgot the plus or minus symbol over 2, and the 2's are gone. So here's your answers. Negative 1 plus or minus a root of 1 plus e cubed. Well, which one is it? All right, which one is it? Let's look at our domain. I know that x is bigger than 0, and I know that x plus 2 is bigger than 0, so x is greater than negative 2. So I don't know which one of those two answers I get to keep. I'm pretty sure I get to keep one of them. Let's see what the TI-84 says. You have negative 1 plus the square root of 1 plus e cubed. Second ln will bring up e. Okay, that's a good answer because that's 3.59. The other one, instead of the plus sign, uses the minus sign. It's probably a wrong answer. It would make sense to me. And that's negative. All right, so here's what I found. My real solution is negative 1 plus the root of 1 plus e cubed. And my extraneous is negative 1 minus root 1 plus e cubed. Well, there's my two answers. Now, this is a tough little problem because it invoked the quadratic formula in a weird manner. And that's a tough problem. Very few kids can do that kind of problem. Now, I'm not saying it to be negative, because I believe that each and every one of you can do it. I should have said very few kids choose to do that. Most kids just don't want to learn it. And I get it. I do. I'm a realist. Next up, we have a log. The understood base on a log is a 10. Got to understand the understood. We are condensing addition. We condense addition through multiplication. Put my little 10 there. And I need another set of parentheses for that to be proper. I'm going to go ahead and do the distributive property here before I exponentiate. And now I'm going to exponentiate. Base, argument, exponent. All right. 10 squared equals 2x squared minus 10x. And 10 squared will yield 100. We'll shift that 100 over. We'll attempt to factor, but we'll pull a 2 at least. Now, are there factors of 50 that add to -5? And there are, because you can use 10 and 5. So 0 equals 2 times x minus 10 times x plus 5. So using the zero product property, my solutions are 10 and -5. So again, let's talk about domain. 2x bigger than 0, divide by 2, x is bigger than 0. X minus 5 is bigger than 0, x is bigger than 5. This guy right here, that's your little extraneous one. It's just not going to work. And that guy right there is real, because 10 is bigger than 0, 10 is bigger than 5. It's not that hard. The last one in your notes for today is a solve using technology. And to do this one, you need to use change of base. It's the reason these are in here. But you got to remember change of base. And this is also something you should write, okay? A logarithm, base b, argument a, is equivalent to, I like ln of a over ln of b. Or, logarithm base b argument a is equal to a log of a, which is what most kids do, over log of b. ln is just more elegant. I mean, that's why I use it. So we're going to do a whole y1, y2 thing. And here's how I'm going to put this into y1. I'm going to put a 3 because there's a 3, ln 3x minus 1, because what's high stays high, all over ln of 2, and then plus 5. 5 is not inside a logarithm. It doesn't need to be converted. Into y2, I'm going to type ln 6x plus 2. It's sitting over the natural log of 5. And then minus 3. And the TI-84 is going to show you real answers. It's going to show you just real answers. It will not show you the extraneous. It will not show you the imaginary. So let's do this the proper way, the way that we know we can't screw up. We're going to go to math. We're going to go to num. We're going to go to n over d. And let's see here. We have 3 ln. Now, if you're wondering why I did all this, is if you look at your faceplate, you don't see a log base 2, do you? And you don't see a log base 5. There is a way to do this without doing change of base. I'm just not going to show it to you because I'm not supposed to. That's why. All right, so we got 3 ln 3x minus 1 over ln of 2 plus 5. Arrowing down. ln 6x plus 2. Oops, I forgot to go to math num n over d, didn't I? I'm old school. I was taught to wrap using parentheses and stuff, and I probably should still teach how to wrap with parentheses. But that notation is just kind of gone. Calculator's got a perfectly good fraction key, may as well use it. All right, I think I got everything typed in. Now, I want you to understand that this problem would be ridiculously difficult if it weren't for this, because these bases don't match. It's hard to do by hand. Anyways, we zoom 6, because that's what you're supposed to do. Now, I'm going to make a little note here. If you look at the graph, it looks like there is no answer. Calculator cannot graph logarithms 100% correct. Can't do it. I'll show you what I mean by that. What should have happened is that this blue line continues down. Calculator is just not capable of doing it. So there is a solution to it. All right, it does exist. It's there. We're going to hit second trace. We're going to go to 5. And I'm going to hit that right arrow until my cursor shows up. Just until it shows up, I'm going to press enter. And it's going to jump to the red logarithm. I'm going to press enter. And I'm going to guess. And the calculator is going to find it. So even though it couldn't draw it, it still was able to figure out the intersection. So the correct real answer to this is 0.3983. 0.3983. Four decimal places on logarithms. And I think the last one is for you to try. So that is the end of this video. I'd love to say I hope you enjoyed, but you and I both know that you did not.